Anand Kumar and my roll number is 21ME61R16 and I am submitting my FSW assignment simulated on Ansys Fluent. First, I have opened the geometry and by double clicking on it. First, we change the unit to mm. First, we change the unit to millimeter. Go to the XY plane, right click and look at. Now we create the sketch of our part. First we will create a circle of dia 240 mm. Then we create two chord of this circle of length 144 mm and now we will click generate. Then we extrude this part in a reverse direction of depth 6 mm. Then we create another sketch for tool pin hole on the part of dia 6 mm. Again click generate. Now we also extrude this sketch in reverse direction of depth 5 mm and operate in cut material. After that we create another sketch for shoulder which is diameter of 24 mm and then we extrude it for imprinting the face. Now our part is created. Now we define the different surfaces like velocity input, pressure output, top surface, bottom surface, FSW tool. For this purpose we will go to the tool and select the name selection option and assign the different names. Hence our geometry assign the different names. Then our geometry is completed. Side faces is automatically named. Now we will go back to the workbench and right click on mesh and edit. Go to mesh and select sizing option. We will select sizing option. In the scoping section we select named section and select FSW tool. Element size will be 0.55 for this case and another will be 0.3 mm. And the growth rate will be 1.1. Select mesh again, go to sizing and then click edge selection option. Now in the scoping section we select geometry selection option. Scoping we select geometry selection option and click this edge and make the element size 1 mm. Now and the growth rate will be 1.2 which is by default. Now finally we click on the generate and update the options. We go to the workbench again and click on setup option. As we can see we have 3,46,619 tetrahedral cells within the domain. Now in general, in modal energy equation will be on. In viscous the fluid is taken to be laminar and viscous heating will be on. Now in material we have created a new material, aluminium 6061. This material is created as given in the assignment problem which have the density of 2700. A specific heat coefficient is taken as a polynomial and its coefficients are taken as given in the problem. Same is done for thermal conductivity. For viscosity we use non-Newtonian power law. We select method as shear rate and temperature dependent and fill the values according to the problem. Now we select the boundary condition. Select inlet velocity inlet. In the momentum tab the velocity specification method is selected as magnitude and direction. Velocity magnitude is filled by 1.33 mm per second Now we will go to outlet, pressure outlet. In momentum tab, backflow reference frame is selected as absolute direction, will be selected as direction vector along 100. Now we will go to wall FSW tool. In momentum tab, we select a moving wall and it will be an absolute and rotational boundary condition. Rotation axis is Z, about Z, and origin is 0, 0, 0, and a speed of 74.35 radian per second, 74.51 radian per second. In thermal tab, we assume no heat flux. In thermal tab, we assume no heat flux. Now wall bottom face, since there is some good amount of thrust force that the tool exert on the workpiece, and the workpiece is also clamped on the bottom plate, wall motion will be moving at a speed of 1.33 meter per second. That is transitional and it is in no slip condition. In thermal option, we select convection and we consider heat transfer coefficient of 10,000 watt per meter square Kelvin. Now wall top face, again select moving wall. Is on wall top face, we will select moving wall be same as bottom face, but the convection coefficient is here taken to be very less, that is 30. Now wall solid, again in same moving wall, the same speed, the convection will be 30 here also. Now solution method, we will go for solution method. We pick the default option, then solution report definition. We add the variables that are asked in the question. Go to new force report drag. New force, we will go for new force report drag. First in the weld force, which is the force acting on the FSW tool, which is the force acting in direction 100. And the second is the lateral force, which is force created on FSW tool, which is force action in the direction 010. Third is the thrust force, again the thrust force, which is in the direction of 001. Lastly, we create a moment report which tells us the torque on FSW axis is 001 and moment center is origin. Now solution. Initialization, we will create a hybrid initialization, and finally we run the calculation and we take 2000 iterations. Now we have to plot a contour of temperature. These are the iterations, and now we have to plot contour for temperature and viscosity in weld cross section. For this we have to introduce a new plane. We go to results, contour 1. We click a create new surface named weld transverse section. Option will be point and normal. Point is 0, 0, 0, 0, and normal will be 1, 0, 0. and click create. Now after creating the plane, we need to select the plane for which we have to plot contour, and for that first select temperature, then we click on compute, and finally save and display. And similarly for the viscosity also. Now we can see the peak temperature and the variations of temperature. We can also individually report definition in solution by selecting report definition. The FSW tool torque is about 37.82 minus 37.82 Newton meter, and these are the results, and thank you. And the cell size, number of cells, number of iterations are there. The time taken for the iteration is 40 minutes and 23 minutes respectively for the cell size of 0.3 and 0.5. And torque we have found as minus approximately same as minus 37.82 Newton meter. And these are the thrust force, drag force and the lift force.